Assalamu alaikum wa rahmatullahi wa barakatuh. We are going to complete our questions of chapter 2 open book questions. Let's start with question number 9. The electronic configuration of silver is. Okay, we will look at the drawing of periodic table. We have silver here, Ag. Okay, if we are going to make electronic configuration, we will take the previous inert gas. We have krypton, and after that we have period 5, we have 5s2. Okay, then we will follow it by 4d. We have here 4d. Okay, when you are looking at the place of silver, here we have 10 electrons, 4d10. Okay, so the right answer will be here krypton 5s2 3d10. Okay, krypton 5s1 5s1 and 4d10. Okay, we make more stable condition for silver by putting electron in by complete filled 4d sublevels with electrons, and it is more stable conditions for it, and the 5s less stable, making 5s with 1 electron. Okay, let's going to question number 10. Okay, question number 10, here we have magnesium ion Mg1224 contains what? Contains, okay, we said we are going to make positive ion by losing electrons, so the number of electrons less than the number of protons. If we have 12 in ordinary state, so in case of ion we will lose 2 electrons and the number of electrons will be 10, and so the number of protons will be 12 protons. Okay, let's go to question number 11. The electronic configuration of iron 3. Iron 3, we have its atomic number 26. Okay, let's go to our table. Okay, we have here iron. Okay, we have argon 18. Then we complete with starting period 4. We have 4s2, 1 2 3 4 5 6, and what, and 3d what, 6 orbitals, 6 electrons. Okay, here we have the iron will be argon, and the last one will be 3d5. Okay, we have going to 1 electron, that making loses for it by losing electron. Okay, we are going to lose 3 electrons. We are going to make ion. This is the normal electronic configuration. If we lose 3 electrons, so will be 1 electron removed from the d orbitals after removing 2 electrons from what? From 4s2. Okay, so the ion of iron, I think it's very important question, you must fix it on it. Okay, argon, and followed by 3d5. Okay, let's go into question number 12. Okay, question number 12 says that the highest number of unpaired electron is in. Okay, we have here, if we are looking to the previous question, we have here which case that we have unpaired electrons. The only case we have large number of unpaired electrons we have here in case of iron 3, Fe plus 3, the iron Fe plus 4 not accepted here, and metal here normal ion, normal atom, so contain paired electrons, but here we have large number of unpaired electrons in what? In iron 3 case. Okay, let's go into question number 13. Okay, the atomic radius of fluorine F9 is smaller than the atomic radius of carbon 6 because, okay, if we discuss the atomic radius or atomic size, we are going to talk about the number of the number of energy levels affected by it. If we are talking about here, we are talking about what? We are talking about carbon here. We will make magnifying for it. Carbon and fluorine. Okay. If we have fluorine in group 7 and carbon in group 4, by increasing the number of electrons, atomic size or atomic radius decrease. As the number of electrons increases, make attraction force between the nucleus and the electrons or the last electrons in the outermost energy level. So we have here, we are in the same period, but we have in carbon we have 4 electrons in the outermost energy level, as we are present in group 4. But in case of fluorine, we are in group 7, so the number of electrons increases as make more attraction force to the nucleus, so the atomic radius will decrease. If we're discussing our question, the right choice will be here. The effective nuclear charge of fluorine is larger than carbon. The effective nuclear charge of fluorine is larger than carbon, so it makes a large attraction force by the effect of increasing the number of electrons. Okay, I think it's very important question. Please concentrate and fix or make fixed or complete attention to this kind of question. Okay, let's go into question number 14. The correct arrangement in increasing the ionic radii or ionic radius is, okay, as we said, when we are looking to the periodic table, we have here Na in group 1, magnesium in group 2, and aluminium in group 3. Okay, what about atomic radius of them? Okay, here we have losing, when we are losing 1 electron, that we have large atomic size, so the number of electrons not taking large amount or not take large amount of energy to remove the electron from its size. So when we remove 3 electrons, the atomic radius will decrease. So in case of ions, by losing large number of electrons, atomic radius will be more decreases. Okay, if we lose 1 electron, the atomic radius will be higher. If we lose 2 electrons, the atomic radius will be decreased. If we lose 3 electrons, like metal in aluminium, so the atomic radius will be more decreased. So if we make arrangement in the atomic size, Na plus more in atomic size or in atomic radius than Mg plus 2, more than what? More than Al plus 3. This is very important question. Here we have correct arrangement of increasing in atomic radius. Na more than Mg plus 2, more than Al plus 3. Let's go into question number 15. The equation X naught plus energy. Okay, X naught plus energy means we are in oxidation state 0, that we give energy to this atom, will changes into positive ion and 1 electron remove. So the absorbed energy here, okay, in case of energy here, the energy of level Q, what happened to it? If we are in 0 oxidation number, we want to increase the oxidation state, like as we going from 1 to 2. Okay, we adding 1 to 1 to make higher in number. So here we have, if we are in oxidation state 0 and we want to move or higher oxidation state X plus or plus 1 or plus 2 or plus 3, any of them, so the absorbed energy greater or more than the energy of level Q. Okay,